7G1, 7G2 today. Does start off pretty straightforward, so we'll just start with this, and then maybe 10, 20 minutes we get into 7G2, but there's a few proofs involved, so it gets a little bit more difficult. So, what we're talking about is complex conjugates, okay? So if we have here, we've got the roots of a quadratic are 2 plus I and 2 take I. They're the two roots of the quadratic. So we know if we have the roots of a quadratic, like if we have roots P and Q, we could write the quadratic as x take P times x take Q. All right? That would be one way that we can write the quadratic. So here we have the roots x take, we've got 2 plus I, and x take 2 take I. That would be one way we can write it as well. All right? But there's actually a quicker way. Okay? So you've got a formula here. It says if roots are c plus di and c take di, then we've got x squared take 2cx plus c squared plus d squared. So we can use that formula to find the quadratic. Or we can remember this as well. And you come across this in chapter 3b, I think. We're talking about sum and product of roots. So we can write it as a quadratic by saying this number, this coefficient is going to be the sum of the roots, and this number over here is going to be the product of the roots. So when we think about these roots, we've got 2 plus I and 2 take I. That's what it's like when we spread them out. Now if I add them together, I'm going to have 2 plus 2 is 4, and I take I, that cancels. So the sum of the roots is 4. Okay? So I'm just going to write that for now. We've got the sum is 4. And the product, if you think of the product, you can think of the product as difference of 2 squares, isn't it? You've got a plus b times a take b. It's going to be 2 squared take I squared. Okay. What is I squared but minus 1? So you have 4 take minus 1. You have 5. Alright, so that means we can write the quadratic as x squared take the sum plus the product. It does say find all quadratics, so we need an A out the front to say how it could dilate the quadratic. Alright, so that's going to be our answer. Excellent. Then we have 5 take 3i is a root. Alright, find the quadratic, x squared plus ax plus b. Well, if 5 take 3i is a root, okay, then its conjugate is also a root. So that means then 5 plus 3i is also a root. Okay, so even if we're only given one, we know the other because we know its conjugate is a root. Is also a root. Alright, and then we can just perform the exact same thing we did before. Okay, so we could think about it in terms of sum and product. So if we add these roots together, the sum is going to be 10, and the product is going to be 5 squared take 3i squared. Alright, which is 25 plus 9. Okay, 25 plus 9, because it's take 9 times I squared, and I squared is minus 1, so that'll be 34. And so this quadratic would be x squared take 10x plus 34. And so therefore the value of A is minus 10, and B is 34. So we've answered the question. Alright, so that's what this is introducing you to, how we can use the sum and the product of the roots to find a quadratic from its imaginary solutions. Okay, so let's do that. There's only 2 questions here, 7G.1. Even if you just sort of dabble with it.
No sense, what's penis?
Yeah, excellent.